Thanks.
Yeah. Is this good? Cool. Welcome to our talk today. We're really excited to be here. Today we're going to talk about code reviews in Go, drawing on our collective experience of building many projects together over the years. We'll talk about how we can improve our code review process and what to watch out for specifically in Go. So let's dive in.
Cool, so looks good to me, which means they didn't read your code. We are going to talk about a few things in terms of us and our experiences writing code together. The top 5 things to look out for in your code reviews that might not necessarily be easy to find or that we've at least found have given us the most headaches. Talk a little bit about the style hygiene as well for code reviews. And I think important to remember that this isn't just for code reviewers, it's for authors as well. You're not relying on code reviews for everything that goes into production. It's a two-way process.
Cool, I'll kick us off with some intros. My name is Quinn. I'm a senior software engineer at Dapper Labs. It's funny that I need notes on this, but I do. I come from a business and computer science joint degree from the faraway lands of Canada. We both are, so really excited to be here. Yeah,
Canucks.
Canucks, our hockey team. Through my degree, I did a few internships and gradually fell in love with backend. I started at Dapper when the company was just 80 people, and as it grew to 500, 600 people, all of our projects are in Go, and I had the pleasure of working on 5 or 6 of them throughout our years there. And the sharing and connecting of knowledge and being able to learn from people and also share what I know is the reason why I'm excited to be here today.
Awesome. And I'm Sadie. I am coming from Vancouver. I'm also really excited. This is my first time in Australia. I learned what a bin chicken was the other day. And can someone please write a programming language and make that the mascot? So I've been writing Go for 5 years. I've also been a software engineer for 5 years. I used to work in HR for a hospitality group, and then I switched and did a coding bootcamp. I got really lucky with my first job that it was in Go. And since then, I've also done some speaking at GopherConAU UK. And I'm always just really wowed by the Go community and how welcoming it is. So, yeah. Okay, so Dapper Labs. We talked a little bit about this. This is how Quinn and I know each other. For some context about what we've worked on, if you don't know, Dapper is one of the companies that kind of kicked off the NFT boom. This isn't really a talk about NFTs, but it's important for context. So CryptoKitties was one of the early days NFT products. Our CTO was actually the person that coined the term NFT. Quinn and I joined around the same time 4 years ago, and we are part of the original team that built NBA TopShot and NFL AllDay, which are both NFT platforms. If you've seen The Simpsons recently, they actually did an NFT episode, and you can see up at the top, the basketball, that's us, that's TopShot. So we built TopShot using, this was our first product that we worked on together. We used event-driven architecture with fully Go backend and around 12 different microservices, talked to each other with Kafka. And in the early few months, we kind of amassed a fairly dedicated but small user base. We'd always kind of built the backend with scale in mind, but it wasn't necessarily at the forefront. We were kind of more focused on building new features and prototyping. Then 2021 happened. And if you are familiar, there was like a little bit of an NFT boom. We went from having thousands of users in a week to just under 1 million. And if you've written code that needs to scale, you know that sometimes there are problems with that. I just remember it was like January 2021, and these graphs just kept going up. And we were kind of, it was like a great problem to have, but a little overwhelming. So we basically had to kind of reorient, and we spent the next 4 months working very aggressively to scale up our products. We were shipping code daily. We were debugging in production. And we were waking up at all hours of the night to PagerDuty alerts. So that was very much like Quinn and I were on the same PagerDuty rotation, and we became very fast friends in the way that happens when you wake up at 2 a.m. and have to be on a video call debugging in production. Also part of just being a startup, and I know that this is not the same for many companies, the ethos is very much move fast and break things, and so we did. But I think it's also kind of safe to say that that was really formative for both of us in our careers. Just having that opportunity to kind of make mistakes and really learn from them. It happened incredibly quickly, and it was very valuable, although I don't think I want to do that again. So my personal claim to fame is one night after very little sleep, I was updating a field on one of the NFTs that was being sold the next day, and I accidentally flipped it to be for sale. And some users that were keeping an eye on things managed to snap up about 70 before we switched it back. So that's what happens. In terms of now, we have basically been supporting this product for the last 4 years. We've both stepped into senior roles and led teams on back-end features for a few different products. And in terms of what this has to do with Go, aside from just it being what we used on the back end, in all that time, we have done a lot of code reviews. And we spent our 2021 looking like this so that you could learn from that. And learn from the things that we picked up at that could have been picked up at the review stage. And in our experience, these are the top 5 things that could have caused us headaches that could be avoided.
The first one is error handling, and a couple talks have talked about this already, so I'm excited to hear. I was excited to hear about it. In Go, unlike languages like Java, where errors are seen as exceptions, we get to treat them as values that can be assigned to variables, which make them really powerful and a lot of leverage that we can use. 2 primary ways that we usually handle errors in Go gracefully for anticipated errors and by panicking for unanticipated errors. In general, don't panic in life, but also in Go code. And I know the idiomatic way we know the idiomatic way of error handling with if error does not equal nil, do something. But what about beyond that? What can we catch in our review stage or in our implementation stage that can make it more powerful and useful? There's 2 things I want to bring to your attention today. One is wrapping errors, and the other one is custom errors. With if error does not equal nil, return error, that can be helpful, at least you're returning it. But with a naked error, if we don't wrap it, it's sometimes hard at 2 a.m. to know the origin of the error and the conditions that have led it to happen. So when you get to wrap it, you can add these details. Also note that you also want to consider how much of the implementation details you want to expose. Sometimes you don't want to expose all the nitty-gritty stuff. With wrapping errors, there's also something really useful in Go, which is the error is and error as for checking the value of the errors and the type of error. So if you see something like if error equal sign error type or some error value, you want to change that up probably and use error is or error as. And the same goes for error unwrap. The best part of these functions is that they continue to be useful no matter how many times you've wrapped it. So you wrap it down at the del layer. If you go up a few to the caller, you can still be able to see the error type or the error value. A small note on wrapping errors, if you can imagine it, visualize it in your head a bit. If you wrap it and then wrap it and then wrap it, if you capitalize the error message, it looks a little bit weird by the time when it's a full sentence, so avoid capitalizing error messages since they'll be wrapped. For custom errors, this I had to think long and hard about back in the day when I was learning about custom errors, about when to use them, how they're helpful, and why we should even consider defining them in the first place. It can be really helpful to improve the signaling, the expressiveness, and the precision of errors. It's a little bit easier to debug in some cases, and it avoids some of the repetition. So for example, if you're wrapping something, an error like user is nil, then you'll just have that wrapped error all over the place, and potentially in the caller, you want to handle it in the same way. If you define a custom error like nil user, it's more expressive, and then up the stack in the caller, you can all handle this in the way that makes sense. The last thing about, well, not the last thing yet, but the last thing about this slide is don't ignore the errors. Or if you really want to and you consciously made that decision, then at least use a blank assignment to it. And that way it pulls the attention, especially during the review stage, so that you can have a discussion around it if it needs to happen. Open communication really goes a long way for error handling and for the next 4 points today to maintain a robust and reliable code base together. A little more on errors etiquette. For when you have logging in your Power and tracing as well, a good question to ask is whether this thing needs to be logged or to be returned as an error. You only want to handle an error once, and here are some strategies to decide which one is better. If you want to do something with the error, then wrap it and return it. That way you can know what happened. If you're okay in some cases with the degraded performance and you want to continue the program execution to continue, then log it and you just go on as is. And if you want to deal with a specific way, like custom errors, you can do that and then match that error first when you're handling it. The last thing I learned the hard way is having recovery mechanisms. When an error occurs, it's nice to handle it at the code level, but at the logic level, thinking about if there's any compensating actions that need to happen. For example, if a state needs to be changed to failed or finished processing, if a database transaction needs to be reverted in some way so that things are happen atomically, those are things to consider and things that are really good to catch during the review stage. There's also defer and panic and recovery in Go, which can be helpful for like closing a channel or closing a database connection. And while they're helpful, they can be helpful, I would caution to use extreme caution for heavy logic, because you might not want to continue the execution of a program if an error already occurs. So there's 3 layers of how I think about error handling when I'm reviewing PR. The first one is, are they being handled? The second, do I have sufficient context to debug it? And the third one is there additional logic that's needed to handle whatever comes from this error?
Cool. So next up are Go routines. And if you notice, we've put questions for each of these things that might be like helpful code review questions. We also have a link at the end with all of these kind of grouped together in our GitHub repo. So Go routines, like, let's face it, we write Go so we can feel superior and say, like, yeah, Go is really good for concurrency. At least that's what people told me when I first started writing Go, and I was kind of like, okay, I don't know what that means. And I'm kind of convinced that you can actually go a long time in your career writing Go as a backend API developer without really needing to use Go routines or concurrency. But when you do, they're obviously very powerful and useful. They are also hard to review because anything asynchronous is going to be harder to test and harder to review because it's harder to visualize, at least in my mind. So one of the first things I would ask when I see a Go routine is, do we actually need this? Or is it something that can be simpler to run synchronously? For us, we have some pretty low traffic endpoints that there's like a to-do to optimize this endpoint that's been there for 3 years. Do we really need to at that point? Probably not. And for the sake of simplicity of code and readability, it may just make sense to not, as opposed to trying to over-engineer it. The other thing is understanding. Do you actually know what this is doing? And I don't really recommend saying that in your code review or accusing your author of not knowing what it does. There's maybe gentler ways to phrase that. But I've definitely seen a lot of like boilerplate code that has Go routines that gets copy-pasted. And that can cause issues when you run into an error down the line and you don't know what it's doing. And because it's running asynchronously, it's harder to debug. The next thing is wait groups. So if I don't see wait groups in a Go routine process, then I want to know like absolutely for sure that's for a reason. Generally, I think you probably do want to have a wait group, whether it's for metrics to know like how long your Go routines are taking to finish, or so that you can trigger an action that is required to have all of those threads completed before it starts. And then the last thing is resource allocation. And this is also something that we ran into a lot. We had a service that had Go routines firing off Go routines, so it was nested, and we realized pretty quickly that that completely bonked our Kubernetes pods. So what we did actually was split up the Go routines into separate deployments. I have a talk on that, actually. If you're interested in it, come chat to me later. But can you load test that? If your Go routines have no upper limit, like if you're running them, if it's exponential to the kind of API traffic you're getting to your app, like do you know what your Go routines are doing when you let them out in the dark? That kind of thing. So yeah, you might want to find that you need to cap those. You can use resource allocation, you can split deployments, and also worker pools will let you control the limit of Go routines that can be spun up.
Nils. We've probably all seen this before. We hit a nil pointer. How did this happen, and how can we avoid it? This has been the bane of our existence. Maybe not existence, but it's been the root of many of our bugs in the past, I swear, because we've done all of this. So in Go, nil is the zero value for many types, including pointers, when you have to look at the slide, pointers, maps, and slices, also functions and channels and interfaces. And so when you're using these types, you want to check that they're not nil before accessing their fields, which brings me to the next point. Okay. So if the field, we did a weird proportion with our speaker notes in our slide. And so with the when you're accessing a field in a struct or an element in a slice, whether or not that's going to be a nil pointer, you want to check it before you access it. And that goes for any unexpected input or field values as well. And then the last one is having nils. With interfaces, it's a bit of a special one. If you're checking nil on interfaces, you can use the switch to check on various types. And since a nil interface value holds neither a value or a concrete type, calling a method on a nil interface without instantiating it will cause a runtime error, so don't do that. So you want to make sure that's not nil before you call it. For pointers and values, we had a whole talk on this yesterday, which is exciting, learned a lot. A good question to ask is when to use pointers and when to use values. Something if it's mutable, pointers. If it's naturally a value type, then values is probably your way to go. Another question to think about when you're doing PR reviews is how are you going to refer to this argument throughout? If you're just going to dereference it, then maybe you want to use a value. Some of the pointer gotchas, and learn from experience, that if you are passing in a slice that is a slice of pointers and you're trying to use that value without dereferencing it, then you'll see something called implicit memory aliasing. So you want to either copy the value that the pointer is pointing to, or you want to just not pass in pointers into the slice. That same goes for sync sync fields as well. It's best never to copy the values of those types in the sync standard package unless they're explicitly made to do so, then you go wild. And the last one, really to hone it in, is if the pointer isn't necessary, then like on maps, funcs, or slices that aren't resliced or reallocated, then also maybe that's something to nip in the butt during PR reviews.
Cool. So then interfaces and testing, which I think falls more along kind of style guide, but if you get it right in the beginning, can really help support your code going forward. And I don't think, like early on in my career, I don't think I really paid any attention to interfaces when I looked at code reviews, because I just assumed if you were using them, you knew what you were doing. I think we all know is not the way to go with a code review. So too many interfaces. And one of the great things about them is that you can use them to support multiple structs with the same behavior. But what you sometimes end up with is an interface that is defined for each struct, and that adds code that can sometimes be unnecessary, so it's worth looking into where you can consolidate that. The flip side of that is also, and maybe a bit counterintuitive to that, you don't want to crowd an interface with functions that aren't being used. Like with most things, it's better to start small and build from there. And then when you're testing, and this is something that we have experienced a lot with our earlier code, we relied so heavily on integration testing. And if we had been a bit cleverer with our interfaces and mocks, we could have converted a lot of that to unit testing. So now we have a lot more unit tests, and our CI/CD runs a lot quicker. So use interfaces and mocks.
So we went through 4 of the big gotchas. There's also a host of smaller things that we compiled and want to bring your attention to. So a throwback to Sadie's earlier story about is for sale. We want to validate the input, whether it's for nils or for unexpected values. That's something we can check, and it's a good idea to check. For comments, sometimes they can be super helpful because they help improve the readability or dispel any confusion, but that doesn't mean it replaces unclear code. So if you're seeing a comment, things I think about is, well, is the function itself readable? Can I understand why it's happening and what is happening? And then if a comment is necessary to kind of help with understanding why something is implemented the way it is, or if something is implemented in an unidiomatic way, that can be really helpful. For comments, if it is there and it is necessary and helpful, then make sure that the spelling and grammar, sometimes we type it fast and forget about those things, as well as in Go, starting with the function name and then ending with up here it is kind of the stylistic preferred choice. On naming, which is a difficult task in general, some reminders to think about is for package names especially, because they are visible outside of the package. You want to name them so that you can reduce the redundancy. So for example, if you have a car package and you want to add a function called adding a steering wheel to the car, instead of calling the package car and the function also car add steering wheel, when you're reading it, it'll be car add steering wheel. And so you can kind of just eliminate the car part of the function, and then it will read quite nicely, car add steering wheel. The same goes for variable names in terms of succinctness and clarity. I've learned the hard way that something that's named really long isn't necessarily more helpful or more readable. On the flip side of that, something that is one letter like C, if you're reading 100 lines down, then you kind of lose the context. So there's a balance between there as well. And something as a PR reviewer, because you have less context than the implementer, it's helpful to see if you understand it, because that means future developers looking at that code, whether they're going to find it easy to understand and right away what it's referring to. For the last one, in Go, declaring empty slices, the stylistic preferred way is declaring it as a nil slice instead of instantiating it.
Cool. And then the last kind of things about more code review hygiene. First one is use your tools. So there are tools that will help catch some of these things, not all, and that's why we have code reviews. We have a handful of linters that we use as part of our CI/CD process. There are lots out there, and if you are going to integrate that with your CI/CD, choose a limit, and then don't go over that, because it's only going to be as useful. It's only going to be useful up until the point that you disable your CI/CD, because you can get your code into production. And the other thing is just be human. So code reviews are between people, and they are most successful when you can approach them with a sense of curiosity. I like to think of code reviews not as a gatekeeping tool. It's not necessarily an approval process, but it's a collaboration between two teams. I'm kind of convinced that you can actually get away with pretty trash code in your code base as long as your team actually knows what it's doing and works together. Not that I'm recommending that. But yeah, I mean, I think a senior's job is not necessarily just to write good code all day. It's to do some of that, but also to foster an environment where the rest of your team can write good code. And that doesn't happen when people are scared of code reviews. So ask questions and approach it with curiosity. Can you provide context to someone that someone else might not have in a way that is productive for helping them understand things at a deeper level?
Awesome. So in conclusion, the heart of what we went over today were these 5 things: errors, concurrency, nils, interfaces, and some stylistic choices. So take care when you're using that, but also, as the implementer, the writer the author of a PR, make things explicit and readable. And as a reviewer, on the flip side, be open and curious and ask questions. And these questions will lead to discussions that can help your team set a standard that makes sense for your project and your team. And that way, when you have a set standard, you don't have to have the same discussions over and over again, which makes reviews quicker, less painful, and your code better in general. The last one is, as Sadie mentioned, it is a two-way process. PR reviewing is about collaboration, and making software engineering is about making program or code together with people over a period of time. And so asking questions, being open to them, as well as being open to the feedback, is all this part of this beautiful collaboration process that we've got to do, and all of us here get to do. And so have fun with it, and be kind to one another.
Yeah, thank you so much.